Okay, good evening everyone. My name is Riya Sharma. I am a PMRF student from IIT Kanpur and I have recently been selected into this PMRF Cycle 11. I am a PhD student from Chemical Engineering Department. Currently I am in my third year and I'll be taking this tutorial on thermodynamics of fluid phase equilibrium for you all. So let's start with zeroth law of thermodynamics. What is zeroth law of thermodynamics? Let me tell you. The zeroth law of thermodynamics is that part if two bodies are in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. By replacing the third body with a thermometer, the zeroth law can be restated as two bodies are in thermal equilibrium if both have the same temperature reading, even if they are not in contact. So this definition is a very important definition because it itself came as a temperature. What you call as temperature came into T property has came into picture because of this. I would be glad if somebody can answer all these questions. Since nobody is in the meeting, I'll further go ahead. What is the first law of thermodynamics? The first law of thermodynamics is the conservation of energy principle, provides a sound basis for studying the relationships among the various forms of energy and energy interaction. The first law states that energy can be neither created nor destroyed during a process, it can only change forms. The first law also tells that change in total energy during an adiabatic process must be equal to the net work done. So actually the first law of thermodynamics is the conservation of energy principle. It is based on energy of conservation. If you guys also know that energy can neither be created nor be destroyed, is a universal law. And the first law also tells for an adiabatic process, if you'll see for an adiabatic process, what is an adiabatic process? If it is in a container, there is some mass present. If I'll take this as a mass, or some system is present, there can be no mass M and no Q exchange. Okay, I hope it answers the thing. So for that, when Q is equals to 0, the first law itself will become that the total change in energy will E equals to kinetic energy, or what you say internal energy will always be equals to the work done. I'll be actually talking about the first law of thermodynamics, taking few questions, but these are the basics which I wanted to tell you all. That zeroth law of thermodynamics and the first law of thermodynamics. I hope it is clear. Let's go on to the questions. So I designed like 17 questions from each assignment. And this assignment 1, what I tried to do, I took these 17 questions based on your first assignment. First assignment is mostly comprising on the thermodynamics philosophies, what it is, and I have tried to replicate it in such a way that you will be able to understand your questions very well. Okay, so going ahead with my question number 1. So a system which does not allow transfer of mass between systems and surroundings. So you need to tell me what is this system called. So I'll be giving everyone 2 minutes of time to think about it, and I thought that we will discuss and share our opinions about it. So 2 minutes of time will be given to think about it, and we can just then start discussing about this thing. So a system, it says, let's redo the question, It says a system which does not allow transfer of mass, m, mass. So mass is not allowed between system and surroundings. So if this is my system, for example, if this is my system, let's say SYS, and this is my surroundings, okay, let me just, you need to cooperate for a while, that this is my surroundings. So it is saying that what will this be called when there is no mass exchange. So whenever something is given, you should always write and try to visualize it. And since I've given you 2 or 3 minutes of time to think about it, so think it as like mass cannot be exchanged, but rest everything can be exchanged. So what other things can be exchanged? It can be Q. So Q can be exchanged. What is that system? Try to think. Is it an isolated system? Is it a closed system? Is it an open system? Or the last option is none of the above. You must have done this thing in lecture number 1. So lecture number 1 gives a very detailed idea about all these systems, and hence I took this so that you get a grasp over it. Okay, so now since almost 2 minutes are over, I'll be discussing what is the answer. Yeah, so the answer is closed system. What happens in an isolated system? Isolated itself means that there is a layer which doesn't allow, there's a separation between system and surround. Open system, whereas what open system is, where there's anything can be exchanged, mass or Q. But only in a closed system. For example, think of a piston, a movable piston. No, sorry, not a movable piston. It's like a closed piston. You think about it as a closed piston. So a closed piston where you can put a heat, you can just heat it, and heat can be expressed. So Q can be given, and mass is not able to exchange. So piston is an example of closed system. So here's my answer. This is our answer. Okay. So this is our answer, and I've also written this as the thing. The next question, let's go. So the second question is actually similar. What you tell a system which allow transfer of matter and energy between system and surroundings? This is the question. Think about it. The previous one we have already done. So I'll start the timer, and let's see who will do it. So think about a system. So let's make a system which allow transfer of matter and energy between system and surroundings. So it is saying it can allow mass m, it can allow exchange of q as well. Okay, this is q. I'm sorry, you have to bind me because my mouse is not working properly. Yeah, so this is q. I hope you understand, and it can be aligned. So this arrow can be both ways. So you need to tell me, think about maybe a pan. You said you can allow everything. Think about what that system is called. Yeah, so let me go back to my screen and I am here. So I am presenting. Is there anyone entered? No. Okay, let me present. Yeah, so we were at the system. The answer to this is an open system. I'll keep the pen pointer right now. I'll use highlighter because it's a bit easy. It's an open system. So what does open system means? Open system is a system where both mass and heat can be exchanged. For example, a frying pan, a open lid cooker, for example, a cooker which has then open lid, or your boilers or something like that. It can be where mass and this mass matter, what you say, a matter and energy in the form of heat, in the form of work, can be transferred into each other is our system. So I hope this question is answered. Open isolated system is that system where there is no exchange. Closed system is those where only mass cannot be exchanged. Open system is where everything can be exchanged. And the last option is none of the above. Okay. So going similar to it, let's take it a bit further. Let's go into the applications. So my third question is, which among the following, when in operation, so this is an application question, which among the following, when in operation, is an example of an isolated system? So we learned from our previous discussion that what is an isolated system? Isolated system, let's make this system, isolated system is that system where mass, heat, or nothing can be in between exchange between the system and the surroundings. Okay, so if this is my system and this is my surroundings, if I'll say that here, there can be no exchange. So think for 2 minutes and then we will again go back to our answers. You need to think about like which among the following when in operation. So think about like what is kettle boiler? What does kettle boiler do? What does thermoflask is? What is frying pan? I have given an example also frying pan. What is a frying pan? So let's go in one by one and then think about it. Yeah. So what is a kettle boiler? Kettle boiler is normal this boilers which you have when you heat it, it gets heated. When you put it nowadays, it's inductions also there. So these boilers, when you, it is used to keep the water. It is not used to keep the water warm. It makes the water warm. So that is kettle boiler. Thermoflask. Second is thermoflask. What is thermoflask? Thermoflask is the insulated material by which you keep the water warm. Third is the frying pan which your mother used, or your, I should not be saying mother, but yeah, which we use to make heat it. So think about like what frying pan does, what thermoflask does, what kettle boiler does, because thermodynamics is basically based on application. Thermodynamics is the subject where you can think about it. Let me also check if somebody came or not in the meeting, so I'll check that as well. I'll keep it and let me go to this. If someone has joined, nobody has joined the meeting, so I'll go back to my discussion and I'll be keeping this as a video. Okay, so think about kettle boiler, think about thermoflask, think about frying pan, and the last option is none of the above. So your 2 minutes is almost about to get up. Okay, so yeah, so answer is, yeah, and here the answer is thermoflask. Yeah, because think about thermoflask is let me use the pointer once again. Yeah, so thermoflask is that one where we keep our water warm. So here, if this is a bottle, there's a cap. Even if you have seen those, they have thermoflask have these insulated bodies inside it where my water bottle keeps it warm. So these question doesn't need the detailed answers or explanation, so I'm just directly going to the answers and ticking it. This is based on first lectures of your of this fluid phase and equilibrium, and you'll be able to answer more questions coming into this. So let's go to your 15th question of the assignment. So I'm not gonna answer anything. I will only be telling you, since you have done all these three questions regarding the systems, and you now know what is first law and second law, everything, first law and zeroth law, I'm sorry, and you have an idea that what is open system, what is an isolated system, what is the isolated system, or what is the closed system. So there's another question that if a system undergoes a process involving heat transfer with its surrounding but no work, that process is said to be adiabatic. So you need to think about it. You will be able to answer that if a system undergoes a process involving heat transfer with its surrounding but no work. So basically you need to understand what does first law says. If I'll give you a hint about it. So what is change in internal energy is delta U is equals to Q plus W. So out of this, if it is saying that it goes heat transfer, but there is no work, think about this and think about this statement as well. Okay. So I hope you were able to answer that true or false question, and you can go ahead with it. And if you have any problem, you can mail me or you can put our questions on it. The fourth one is on intensive and extensive property, which has been covered in lecture 2. It has been in a very detailed way, because when you understand the thermodynamics, you should know what is an intensive property, what is an extensive property, because these things are very minutely able to solve many of these property when it comes to system and surrounding. So for example, system, what is a system and what is a surrounding? So they must be having different things like system has T temperature, P pressure. Can I change this? Do I need to change the temperature? Can I change the pressure? So these things matters a lot, and if you're able to understand the basics of it, you'll be able to go ahead with any other things which are coming on the way. So I wanted to ask, the fourth question is based on the very conceptual point, that is, which of the following is an extensive property? Is it the pressure, the volume, the density, or the none of the above? Yeah. I am again giving you 2 minutes of time. You can solve it, you can think about it, and you can go ahead with it. And think about what is extensive property. Think about like, is extensive property depends on mass. So till the time I am giving 2 minutes of time to think about what to do. Let me check if somebody has entered the meeting as well. So let me check if somebody has entered. No, nobody has entered. Let me see if the meeting link is fine. It's fine. Let me go back to my things and go ahead with it. Okay. So which of the following is an extensive property? Is it pressure? Is it volume? Is it density, which is called as zero? Think and think about what is an extensive property, what is an intensive property, and you can go ahead with it. So what is an extensive property? Now let me answer. Extensive property are those properties which depend on mass. So by changing the mass up or down, the property value is changed. Property changes. I'm so sorry that I can't write it, but I have a, so it, like, if you change the mass of the system, the property will get changed. So do you think pressure gets changed with mass, volume gets changed with mass, or density? So density, if you think about density, for example, for a cubic box, if density is, or for water, if the density is 1000 kg per meter cube, have you thought about, like, if I'll take 1 liter of water, is it 1000 kg per meter cube, and if I'll take 2 liter of water, does the density changes with mass? No. Or the mass, if you say, like, so mass units in terms of water is in terms of, like, the volume capacity. So does it changes? No, density always remains constant. It is independent of the mass, which that is why it cannot be an extensive property. So first cross volume. Okay, so I have 1 kilogram of you think about an object which occupies a volume of x centimeter cube. If I increase its mass to 2 kilogram, will it become 2x? Will it takes 2x volume or not? Volume is dependent on the mass of it. Volume is dependent on the mass of the object, of mass or the quantity of the object, whereas pressure is always remaining the same. So keeping it, the pressure, the answer is volume. So that is an extensive properties definition. So let's go to the 5th question and think about it. So I hope you understood what is an intensive, what is an extensive property. Is it dependent on mass? Is it independent of mass? Is called an intensive property. Is an extensive property. You are done with what is an isolated open system. You got done with the first and second law of thermodynamics. So these were your initial lectures, and I wanted to cover the conceptual questions by this. So let's go to the 5th question. If the direction of the process can be reversed at any point by an infinitesimal change in external condition, then process is known as. So it is asking, so this question is asking if the direction of the process, so if there's a process going on, and that can be reversed at any point by an infinite change in external current, that process is known. What that process is called? So let's give you 2 minutes of time and you can answer it, and I'll then discuss. But let me go through the words of it. So it is saying, if and a very good system is a piston, movable piston. If I put sand one by one into this thing, if I'll put from a bulkier system, where is that highlighter? If there are different grains here, what am I doing, rather than putting a whole bunch, what am I doing is taking one grain and putting one. So maybe it will go down by one. Okay, so it is going down, it is compressing, okay, but very smallly. And if I keep that grain out from it, it will again come back to its original position. It will go up, and that movable piston. So it is saying if the direction of the process can be reversed at any point by an infinitesimal change in external condition, then process is known as. I can also do this thing as a big box and keep it down, put it here, and suddenly it will go up. And do you think after putting that box back, will it go up? No, there'll be a friction losses, frictions things. Or is it a spontaneous process where it has no sense here? A spontaneous process says that delta S should always increase, entropy should increase, but it cannot be reversed. So think about it, and the answer to that is a reversible process. So a reversible process actually is a quasi-static process where by small intensible units you can change the directions. Okay. Sixth, properties whose value is prescribed. In prescribed state is independent of the previous history of the system. What is that function is called? So property whose value in prescribed state is independent of the previous system. So what are these functions called as? Is it a state function, path function, or is it both? Is it none? Think about it. I'll give you 2 minutes of time. And this 2 minutes of time, let me see if somebody has entered the meeting or not. No. Okay, makes sense. Let me go back, present. So let us go through the questions again. The property whose value in prescribed state is independent of previous history of its system. What does it mean? It says that my object or my system is in state A. Now it has gone to state B, and it has gone state A to state B by 3 different routes. So if I'll take this, okay, no, not laser pen. So this is one state, this is second way, and this is the third way. So if one has gone to A state, one has to go to A. So if this is a point A and this is the point B, it goes in 3 different processes, and it has a property as property A, and it has property as property B. So the property will be dependent on which way it has come. So first question is that how is it independent? So it is saying that property A and property B, which we have calculated, is independent of path. What is that called? So that function, is it a state function? Is it a path function? So what is a path function? Path function is that function which depends on the route, on the path of it. So it is intuitive, and which doesn't depend on it, it's the state function. So the answer to this is a state function. So here's the answer, and we can go ahead. So state function are those functions. So you will understand what are the state functions and path function in the future thing. But the state function is independent of the path or the previous history. Wherever you come, if you are in point A and if you are at point B, you come by any way. You go by hilly slopes. If you are a cycler, you go by hilly slopes. If you are going by a sea waves, but you are reaching to point B by any formal way from point A to point B. You are there. So that function is called as the state function. Okay, next. Internal energy. So this is an application to our sixth question, basically. Internal energy change, delta U, basically. Delta U. I'm talking of delta U. Change of a system over one complete cycle process is. So let me give you some time you to think about it and let me dissect it for you guys. Internal energy, delta U from first law, delta U is Q plus W. But here what it is saying, that I am doing a process where my point A and point B are the same. So for your kind information, internal energy is a state function. It doesn't depend on whatever its path. So since, now think about what internal energy can be. Internal energy change if it is a state function and my 2 points, point A and point B, collides to one position. So I don't care right now if I have taken a cyclic process or even if I have not moved. I am on the same process. You think about displacement. State functions are actually called the displacements. If you are taking cyclic thing and you are again coming back to the same point, an internal energy, since it is a state function, what will it be the answer? The answer will be 0 because it is a state function. Internal energy is a state function. Internal energy is a state function. Hence, there will be no change in internal energy when a cyclic process is going on. Going to the next question. So yeah, it's in detail. If you wanted to answer, if you want to give, I'll give you an explanation. That system undergoes a series of change and returns to itself. The internal energy of a state function is a property of the system that depends only on its current state and not on the path taken to reach the state. In a cyclic process, the system starts and ends at the same state, meaning that initial and final states are identical. So this is a very good explanation from the book K.V. Narayanan. So I took this question from K.V. Narayanan and this is the answer for it. Okay, let me go ahead. So let's now are we done with the conceptual knowledge that what is an intensive property, what is an extensive property, what is the state function, what is the path function, what is the first law, zeroth law. So now is the time to do the questions, which will be full of references to your assignment problems, and there will be few questions which will be on few new topics, but now I'll be taking few questions and which I'll be solving out with this, and I have my handwritten notes, so I won't be, but I'll be explaining, since it's my handwritten notes, I'll be explaining each and every point where it is there. You can ask me or think before if you have any doubt in any of the problem, or you can post it as well that you have a doubt in any of these, but my references will be assignment questions and you'll be able to grasp all your week 1 lectures in every problem. So I made these problems in such a way. So question number 8, the prerequisite which I want to give, that you should know what is the first law of thermodynamics, which I have revised also, that energy cannot be created, nor be destroyed, and delta U is equals to Q plus W for first law of thermodynamics. If you want to go, I can go back to it. That first law of thermodynamics, what it states, that energy can neither be created nor be destroyed, and we have already told it. So let me go through this 5th, 6th, and 7th. We have done this 8th question. Okay, so okay, so there, let me put the highlighter, write what is given, what is there, and go ahead with it. Solving. Heat in the amount heat in the amount of 8 kilojoule is added to a open system, while its internal energy decreases by 12 kilojoule. So what is the work done? What is the work done on the system in kilojoule is 2 minutes of solving. What is given, write what is given. What is given is that heat given, so Q is equals to, given will always be plus 8. Okay, and to an open system, while its internally energy decreases, so delta U is equals to minus of 12. What you need to do is you have to just apply delta U equals to Q plus W. And that's it. And you'll be able to solve the problem. Let me wait for some moments that you can solve. I'll be giving you 2-3 minutes of time where you can apply these, and I have my handwritten notes, and you can we will discuss line by line what is it. Think about the sign convention. When it is given to the system, it is positive. It is given by the system, is negative. Work done on the system, it is asking, not by the system. So try to understand the conceptualizations, and we will go to the solution. For those people who have solved it, I'll be giving you the answer. You can recheck it. For those who did not get the answer correct, we will solve it once again. So that will be the method. It is like 2 minutes or more than enough to solve this problem. And you have also a similar question. I feel that in the assignment it has been given. So let's solve it. So the answer for it is minus 20 kilojoule. Let us see how to solve this thing. The solution. Here is the solution. Q is, as I have told you, Q is given, delta U is given. You need to apply. So what it has been, so try to understand that there is a beaker, an open system. I have given 8 kilojoule of energy. Its internal energy decreases. So it is asking work done on the system. On the system will be, but it is asking work done on the system will be negative. So delta U is equals to Q plus W. If you take W to this side, so it will be delta U minus Q. Here in this step you are getting it. So if you'll solve it, it's minus 12 minus 8, minus 12 minus 8 is equals to minus 20 kilojoule. And this is the solution for our problem, where we have given Q. So write what has been given as Q. Q equals to 8 kilojoule. Delta U is been given as delta U equals to minus 12 kilojoule. we know what is an internal energy. The internal energy is delta U equals to Q plus W. You just have to rearrange that formula, and it is a very simple 2 or 3 marks of problem. Even in J, even if in our 11th and 12th physics we have done this, and it is the basic formula that heat given is positive, internal energy decreases, so the work done on the system will be a negative energy, negative work which will be done. If they have asked that work done by the system will be a positive, because it has increased its volume, so it would have increased. But on the system it's a negative work because my internal energy is minus 12. So you can, in another way, what you people do is like they know that work done on the system or by the system get cleared by it and put the formula. Don't worry about the signature. What should be the answer? Just worry about it. So I know that 8 kilojoule has been given on the system. So so we knew it that on the system Q will be plus 8. So I have written plus 8, and we said that internal energy has been decreased, so work done on the system will be negative. So rather than solving it, keep putting all these values and all, you just put the basic criteria. Don't think about negative signs and all that, and just yourself will put minus 20. Solve it, you will get 20, and you'll just put the negative sign. That I used to do in my time, where I used to solve, and still whenever I used to solve my questions, I still do the same. Next question. So yeah, now you can think about this assignment question number 2 of your given solution, that a 3-meter cube rigid tank contains nitrogen gas. So what all things are given to you? A 3-meter cube rigid tank contains nitrogen gas at 600 kilopascal and 300 Kelvin. Now heat is transferred to the nitrogen in the tank, and the pressure of the nitrogen rises to 800 kilopascal. Okay, so work done. The work done during this process is how much? It is asking. A 3-meter cube rigid tank contains nitrogen gas at 600 kilopascal. The heat is transferred to the nitrogen in the tank, and pressure of nitrogen rises. So there's a nitrogen tank which has a volume of 3-meter cube, which is saying that it has a pressure of this thing. I have now heat has been transferred to the nitrogen, and its pascal has been given. But what is critical here is, if you will understand, it's a conceptual question, which is the hint is rigid is equals to constant volume. Rigid means constant volume, and if you know that work, what is work? Work for any reversible process, irreversible process, is minus P delta V. When I'm saying it's constant volume, you can guess what shall be the answer for this. So I'm not answering it, but I have answered most of the thing, that it is easy to now understand and solve this. So sometimes when it is given very heavy words, that now it has been given, people, rather than just thinking and understanding the question, the hint itself is in the word. The rigid tank, rigid means itself means it's a constant volume. So that is it. You understand the second problem of this assignment. It is very easy. This is a conceptual problem, and conceptual problem needs every word to be written, every word. So what you do, take a paper, write what is given, what is one given, this part. To solve 300 Kelvin, 600 kilopascal to 300 Kelvin, 800 kilopascal and the temperature has been given. So how much work has been done? So people just, what they do, they just put the pen on and they just start to do RTLN. They put, or something where people are just thinking that oh, the temperatures are same, 300 RTLN P2 by P1 or V1 by V2. They started by pressure, making the pressure as changes by P1 ln P1 by P2. They start making it, and there the problem starts. Think before you do this question. So this is a very, very beautiful question which has been given in your assignment. Try to solve it. Maximum of the problem, it's a one, I'll say maximum 10 or 20-second problem. Okay, let's go to my ninth problem. That is also similar to your assignment problem, but few conceptual things are there which has been missing, or in, and we need to catch that, and let's try to answer it. So what it is saying: a 0.5 meter cube cylinder contains nitrogen gas at 600 kilopascal and 300 Kelvin. So there's a, let's make it 0.5, write how much it has been given. Cylinder volume V equals to 0.5 kilometer value at, what is this pressure, you write this pressure is equals to 600. That's the way to solve the question problem at the 600, and temperature is equals to 300 Kelvin. Okay, now the gas is compressed isothermally when these critical world. First of all, it is compressed. So what now it has become? It is compressed. So my new box is this one. It has compressed here to a volume of, so I am writing my V2 by this of 0.1 meter cube. The work done on the gas during this compression process in kilojoule is at 724, 83, 240 and 175. 3 minutes of time has been given. What is the formula? If you know, it is a simple problem, so just write V1. It is saying isothermally, so T remains again equals to, T is equals to 300 Kelvin. Pressure might have changed. Let's see what you will do that. Just remember, when there's nothing written, imagine that the ideal law, gas law, PV is equals to nRT will follow. It's a good hint. Just understand what is given to you. If T is constant, R is constant, N is constant, so RT, just imagine P1 V1 is directly proportional to RT. So if my work equation for ideal gas in an open system is given by RT ln V2 by V1, so can I replace that RT by this formula or not? And your answers are there. Basic conceptual problems with conceptual answers. Try to solve it, then we will solve it together. A 0.5 meter cube cylinder contains nitrogen gas. Try to write every part. 600 kilopascal. What has been given? 300 Kelvin. Temperature isothermally. So isothermally means that there's compression happens. So work done on the gas will be positive or negative. Think about the signatures also. So this is also, and what you give the formula, what is the formula given, then think about ideal gas law, and then your answer will be there. So if I'll start by giving you the answers, it will be, so by this time let me check that if somebody has entered the meeting or not. No one has entered till now, and yeah, I'll go ahead. A hint has been given to you that ln V2 by V1, what is it? So the answer is 483 kilojoule. Let us try to solve this problem. So here it is a very thing that I have written, what is P1, what is V1, what is V2. Work done during compression, it's a formula given by minus RT ln V2 by V1. As we know, PV equals to nRT. So considering ideal gas, and RTT is thermos, it was saying isothermal, so T is constant. So just what you have to do, you have to replace RT by P1 V1, and work is given. Work is given by this value. I'll hide this, and yeah, 483 kilojoule is my answer. Try to solve it by yourself. Work done during compression, how much is it written? This is the given value, P1, V1, V2. It was saying 0.5 meter cube, 0.1 meter cube. So we have written right V1, V2, whatever these values were. So pressure 1 was that initial temperature, V1 was that initial, and V2 was that 0.1 meter cube. So work done during compression will be work W is equals to minus RT ln V2 by V1. And as we know, PV is directly proportional to RT. Considering that as an ideal gas, work will be equals to minus P1 V1 ln V2 by V1, and work will be given by the similar way. V1 is equals to 0.5. Put these values, try to do by calculator. I have done that similar question very easily, that how you should write it so that you can guess the optimum marks also. 2 minutes of understanding the question, write the given value in a compression. Since it's a compression on the system, the work will be positive. So we know that just the basic thing, that since we are giving the heat, it will compress. So we have compressed the system, it is on the gas, it has compressed also, we have given, so work done will be positive. The answers were in positive sense, so you cannot neglect it, but yeah, 483 is the answer. And I am, so 483 is the answer here, and this is the solution. If you'll think P1 is equals to 600 kilopascal, V1 is equals to 0.5, V2 equals to 0.1. Again, think about work done during compression, how much it will be, and you need to apply the ideal gas law, and you will be there. If any problem, you can write to me, or if anything, you can discuss with me. Now, I will come to the next question. That is my question number 10. It says that an ordinary egg with a mass of 0.1 kg and a specific heat of 3.3 kilojoule is dropped into boiling water at 95 degrees Celsius. If the initial temperature of the egg is 5 degrees Celsius, the maximum amount of heat transferred to the egg is in kilojoule. So this is also a similar question to your assignment, which you can do now very easily if you know of one concept which I will tell you, but I want you guys to first solve it with your proper way. So try to write what is given. What is given to you is that there is an ordinary egg with a mass of 0.1, if you'll see, and a specific heat of 3.32 kilojoule. So specific heat has been given to you of 3.32 kilojoule. And so what is specific heat? Specific heat is equals to Cp value is given to you of 3.32. What other thing is given to you is 3.22 kilojoule per kg degree Celsius. Okay, it's dropped into boiling water. So boiling water temperature they have given. So they have given you T initial 95. Okay, we dropped into, so this is not the T initial. They have given you the final temperature of 95 degrees Celsius. I'm sorry with my writing. My writing is very bad because I am writing with the mouse, but I have a very completed view of solution. But I want you to understand this problem. Like I am highlighting this value, whatever I am writing. So mass is 0.1, Cp is equals to 3.32, and the final TF is equals to 95 degrees Celsius. So an ordinary egg with a mass of 0.1 kg and a specific heat of 3.232 kilojoule per kilogram degree Celsius is dropped if the initial temperature of the egg. So it is saying if the initial temperature of the egg is 5 degrees Celsius. So it is saying that Ti is given as 5 degrees Celsius. The maximum amount of heat transferred to the egg in kilojoule. So you need to find out the heat Q value. Yeah. When there is no phase change, the formula given, just think about in that way, that you have an egg here, there's a egg here, and you are trying to, yeah, there's an egg here and you have given some heat. Initially it has some value. Now there's no phase change because egg is a solid object. There's less chances of doing that. What will be its value? Again, 4-5 minutes of thinking before you go ahead with it. Write all these value. What are these value? And I will be like after 1 minute I'll be telling you which formula to use it. Try to use that formula and then we will discuss the solution in details. So I will also do my question. I'll be writing my question and answering it, and you also do that question in a minute. So after giving you 1 minute of time, it is like the heat exchange for it is given by a formula that when there is no phase change happening, it is given by Q is equals to mCp delta T. So this is again a hint to you to solve it. Those who have not understood the concept, Q is equals to mCp delta T. So try to think. Now it's just putting directly the value. You have M value, you have Cp value, C what is the final temperature, initial temperature you have written, check the units and you will get the answer. So now you can understand that it's an egg with a mass of 0.1 kg which has given a Cp value. It has been put in a boiling water at 95 degrees Celsius. If the initial temperature of the egg is 5 degrees, the maximum amount of heat transfer to the egg is in kilojoule can be. So those who now understood the problem, it's just applying a formula called Q equals to mCp delta T. There are so many problems in your assignment which is actually based on this thing. That first, if you have understood what is heat, then if you have understood heat exchange, and then if you have understood a steady state. 3-4 questions I've seen, like question number 9, 10, they are actually based on these things. So now if somebody has able to do that, a similar question, that's why I've taken for your thing. So those who have applied the formula, answer is 30. Let us see how it has been solved. So very basic thing which you have to do is this. Let me use my highlighter. That heat transfer is given by this formula. Q is equals to mCp delta T, where m is the mass, Cp is the specific heat, delta is Tf minus Tm. You have already written m equals to 0.1 kg, Cp is equals to 3.32 kilojoule per kg degree Celsius, Tf is equals to 95 degrees Celsius and T initial is 5 degrees Celsius. So Q is equals to, well, you solve it, you have to just apply. Okay, so one question here, very thing, can my heat be positive or what it should be? Here it is, all the options have been given in positive. If I have given one option as negative, can the maximum, can heat be negative here? Just think before you do that and try to apply this formula, that what it should be. So the basic formula is mCp delta T. You should always remember this, because when there is no phase change happening, the heat transfer on any object or in any quantity is given by mCp delta T. You just have to put. Another thing which you should remember is that if there is a steady state happening, so heat in is always equals to heat out. Q in is always equals to, okay, what is happening? Keep Q in, okay, I'm sorry, some issues happened. Yeah, so Q in is equals to Q out for any general process which has been done. I'm sorry. Yeah. So Q in is equals to Q out for any steady state process. So next question is actually on this concept. So I hope you understood this question. Let's go again and revise it. And that mCp delta T, if you have put the egg in water, you are able to get it. So you just have to apply this formula, mCp delta T. You have to just put mCp Tf value, Ti value. Put the Q value here, 0.1 into 3.32. And your answer is 29.88, and to be precise, 30 kilojoule per kg. Kilojoule, I'm sorry, 30 kilojoule, and that too plus because you are exchanging the mass. It is asking heat transfer is given by the system. Next, so there is another question in question number 6 in your assignment, that an adiabatic heat exchanger is used to heat cold water at 10 degrees Celsius, entering at a rate of 5 kg kilogram per second by hot air at 800 degrees Celsius, entering also at a rate of 5 kilogram per second. If the exact temperature of hot air is 20 degrees, the exact temperature of cold water is. I am not here to solve assignment problems, but I have taken the problems in such a way that it will able to solve, because now if I have given you this concept and this concept, if you think about Q in and Q out in a steady state, and this Q in and Q out is given by this formula, this question can be very easy for you guys to do it. So an adiabatic heater, that means adiabatic heater itself means that energy is just transferred in this form. There is no heat exchange transfer. So if I have given whatever heat cold water, it will be always given back to it. So entering, if it is given, so there is no heat adiabatic heat exchanger if there is, and if there's coming, so it itself means that there is no heat exchange in that adiabatic heat exchanger. Q will be equals to 0, because adiabatic itself means, in question number 4th and 3rd we have seen that adiabatic itself means that there is no heat exchange. Q is equals to 0 here. So these words, remember that. Then if it is an adiabatic exchanger, if my stream is coming inside and it's going outside, there is no, it's like it's equals to 0, it's equals to 0. So yeah, so this word was important for us. Heat exchanger is used to heat cold water. So it is saying I want to heat the cold water. So if this is a cold water coming, entering at a rate of 5 kg at 10 degrees Celsius. So you just have to write that it is entering at 10 degrees Celsius. Rate you write that it is M, it is T you write, this is mass you write, kilogram per by hot air, entering also at, so if I'm entering, it's an adiabatic also entering at a rate of, so only Q exchange will be there, that it is coming at 5 degree and 100 degrees Celsius it is coming. If the exact temperature of hot, so basically if those entering and exits are being there, what heat has been exchanged is like hot air is at 20 degrees Celsius. So okay, so from 100 degrees Celsius to 20 degrees Celsius of this 5 kilogram per second thing has been changed. So what you have to do is one basic thing, and what you have to find the exact temperature of the cold water. So if this is the body, here it is going 1 and it is coming out, coming entered, it given as 10 degrees Celsius. Here it's asking what is it, and here if it is entering at 5, if it is giving coming at 100 for the hot water and it is going at 20, so this exchange of heat happened. So you just have to indicate Qn is equals to Q out, and using this thing of Cp delta T of cold water is equals to Mcp delta T of hot water. You can say hot air also here. So I have given, this is the heat in is equals to heat out. You have delta T of hot air, everything Cp of air. You should know that air is having Cp of 1.005. Mass is 5 kg per second, so mass can get cancelled. Cp of water is 4.8. So you can go ahead with it. Yeah, you should always remember the air and water Cp values. So I'll give you 1.005 and 4.8. I hope we are good to go with our another question. And the sixth question is from your assignment. So I'm not solving it, but I have given you a hint. Now let's go to the Joule's experiment. An experimental conducted by Joule. Energy is added to water as A, but extracted from the water as B. Okay, so let me see if somebody has entered. Yeah, actually, since nobody is here this well. Yeah. So in experimental conducted by Joule, energy is added to water as A, but extracted from water as B. So what Joule did, let me tell you what Joule experiment was. You have done this in your lecture 4th. So what Joule did, this was the experiment which gave us the first law. What it has just done, it has given water some energy, and then at T equals to 0. What it did that what it did at T equals to T, it has removed the same energy by some method. Okay, that E energy it has removed and E energy it has given. Okay, so what that energy is, A and B, what it has given. So, and as I told you, the first energy, remember the first law which we have done, that internal energy is equals to Q plus W, and it will give you the answer. So giving you 1 minute to understand, but this is the thing, that is it given in the form of work and work, is it has been given in the form of heat and heat. These are the conceptual questions. You should always remember that it has been given in the form of work and heat, or is it been given in the form of heat and work. So what it did at T equals to 0, what it has done. So, but I have given you a conceptual idea about what is the Joule work, what is the Joule experiment was, and this should be remembered by it if somebody knows it. So think about it and you'll be able to get into it, because my 12th question is also related to that only. I hope you get that. Okay, so giving you from lecture number 4, the answer is work and heat. So in experimental conducted by Joule, the energy, this is a remembering question, but as the protocol that you have signed, that 30 seconds I will be giving you to think about it. You should remember that work, in the form of work, it has been given. This is the answer that Joule gave in the form of work, and it has extracted out in the form of heat from it. So that was my Joule experiment. The another question is also related to it, that since we now know that it has given conducted by Joule energy is added to the water as in the form of work at T equals to 0 and T equals to T. What it did was at T equals to T, what it did, it removed in the form of Q. In between this time, extracted from as heat transfer after some time T. During the time T, the energy is stored in what form? So it is asking me that what was that form? Is it a potential energy? Is it that the kinetic energy? It is the internal energy? Is it all of the above? So take 30 seconds to answer this and then we will go ahead with another questions. So we got to know that from Joule experiment that water that has been added in the form of work, so W, and it has been Q. And if I'm saying that it is related to first law of thermodynamics, it will be very easy and predictable, and an intuitive answer to it is it is in the form of internal energy. So internal energy is your answer because potential and kinetic energy is actually internal energy, and here we got internal energy from this Joule's experiment that internal energy is equals to potential plus kinetic, and when you do that, work and heat can be given in the form of internal energy. So from this period of time in water, if you'll think about it, it was stored in the form of internal energy. Okay, yeah, let's go ahead. So yeah, a better explanation, because if I'm speaking there's more to it. When work is done on the water, it can lead to an increase in its internal energy, causing the molecules to move faster or interact differently. Likewise, when heat is extracted from the water, it can result to a decrease in internal energy, causing the molecules to slow down or undergo change in their state. So both of their states, like potential energy or in kinetic energy, both, like velocity has been given and it has been rearrangement, and that whole thing is basically internal energy. So when work is done on water, it can lead to an increase in its internal energy, as I have written. When it can lead to an increase in its internal energy, and it will lead to its move faster. And if you'll think about it here, it can lead to another value. Let's go to the 13th question. This is related to your question number, I guess so, 5th or 6th question, or no, it is related to your 9th question of the assignment, but you'll get to know that it is related to your 9th question of the assignment. Let's rewrite this question and do it. Steam expands in a turbine from 4 megapascal and 500 degrees Celsius to 0.5 megapascal and 250 degrees Celsius at a rate of 1350 kilogram per hour. Heat is lost from the turbine at a rate of 25 kilojoule per second during this process. The power output of the turbine is. It's a beautiful question. It is a very good question also for conceptually to understand that how much power the power output is when there's something loss is there, because when in general you just directly equate the formula, but it has specifically given you some losses also which you need to do. So let's dissect the questions, write it, and we have some time also to, you guys have some time also to solve it. Okay, so the steam expands in a turbine from 4 megapascal. So initially it has been given 4 megapascal and 500 degrees Celsius to 0.5 megapascal and 250 degrees Celsius. And their rate has also been given, m dot has been given. Heat is lost from the turbine at a rate of 25, the power output. So what we have been given, that we have given one initial condition, that and first of all, you should know how to use steam table. So that has been very well taught in lecture number 5 of our tutorial of your these things, NPTEL week 1 lecture. So I won't be going into the detailing of how to find, but I am telling you that for reading the steam table, you should know what you have to find out. So they have given 4 megapascal as their first condition, and that too 500 degrees Celsius. And second is 0.5 megapascal. And the second is 250 degrees Celsius. Got it? And they have given m dot value, the rate, as m dot is equals to 1350 kilogram per hour. Heat is lost from the turbine at a rate of 25 kilojoule per second. So Q loss L is equals to 25. So during this process, and it is asking what will be the power output, what will be W out. So you just have to remember one formula, and the answer is 157 kilowatt. But what you need to do from the steam tables, using the steam tables, you should know what is the HG values, HG and HF value of the steam at 4 megapascal and 500 degrees Celsius, and at 0.4 megapascal and 250 degrees Celsius. When you get to know HG and HF value, it's directly an implication of it that power output will be the power in given to it minus the losses there. What will be the power in which has been given? It will be MH. M into H, that will be the heat transfer rate, heat given, right? MH, and the power loss will be Q loss. Whatever the energy left or the power output left will be your power output. So what you have to equate is, I'll tell you what you have to equate with is, what you have to equate with, I'm sorry, what you have to equate is W out is equals to Q in given to it, because it expands, minus the Q loss L. So we know that QL given to us. What is Q in? Let's dissect it. Q is given to it is m dot into the enthalpies, because steam is there. So you have to, in enthalpies, you have two values of Hg minus Hf. So you need to, from the steam table, I will just refer to your steam tables which has been given to you. This is the HF value, because, and this is the Hg value. You have to find out the HF and Hg value at these conditions, and you will be going on to do the questions. I hope everyone is able to put these things into the formulas. I will give you handwritten problem what I have done. Let's discuss in detail very easily, and you'll be able to take that further ahead. So from turbine balance we know, so you have to put the energy balance into the picture, that W out is equals to in, so this will be m dot t. It has already been given m dot t as 1350 kilogram per hour. Okay, and the Q loss has been given in the form of kilojoule per. So Q loss has been given us in kilojoule per second. So 25 kilojoule per second. So first of all, two conditions we have been given. So use your steam tables, that at 4 megapascal and 500 degrees Celsius, how much is the Hg value? So Hg value from the steam table, it will come around 3445 kilojoule per kg, and at 0.5 and 250 degrees Celsius, HF value will come around 2961 kilojoule per kg. Take your time, give yourself 2 minutes, and I won't run fast. Do it here right itself, that how much in from the steam tables. My answers can also be wrong. I have used my steam table, and I have done it from myself. You can verify me, correct me anytime if you want. Okay, and let me, so by that time, if you are using the steam table, let me see if somebody has entered the meeting or not. I'm keeping this. Nobody has entered the meeting till now. No problem. I'll go ahead, I'll upload this video as well on my YouTube channel. So on my YouTube I'll be uploading. So giving this ahead. Yeah, so I hope in your steam table you got an exact value. You can re-verify it, your values also again, that at this condition and this condition how much is the value. You know the empty dot value. So here it's a very important point is to check the units. 1350 kilogram per hour, and everything we have a Q loss value in kilojoule per second. So what you do, whatever your kilogram per hour value, convert into kilogram per second. How will you convert? You know how much is 1 hour? 1 hour is equals to 60 minutes. 60 minutes, and how much 1 minute is equals to? Is equals to 60 seconds. So here this 1350 divided by 60 into 60, the value will come around 0.5192. Please verify your readings, verify your values when you do it. So use your steam tables, find the values, and take the Q loss as 25 kilojoule per second. So power output will be equals to 0.5192 into 3445 minus 2961 minus 25 value, which will be equals to 157 kilowatt. I hope you got your answers well. It will be an approximate answer, so please verify your steam tables. So it was nothing, it was just an turbine balance which we did power output is equals to Q in minus the Q losses. Generally what we do, we forget is the Q loss value. So, and you should know how to use the steam table. Steam tables use procedure. You can verify these values. I am not showing exactly the steam table. I can also make a video if you want in our next lecture. If you didn't get it, how to use the steam table, I can do it once again. I can show you, but it has been very well verified by professor who has taken the lectures. And in the lecture 5, lecture 4 also I have seen that it has been given very nicely how to use it. So their Hg values and Hf value. What another thing which you have to keep in mind is the consistency of the units. So mt dot is equals to kilogram per hour, which you have to maintain, and you have to go ahead with Q loss is equals to 25 kilojoule per second. Power output will be equals to work out or it's the power output W out will be equal to equating the formulas. I hope you got this answer. Once again, we can clarify that B is our answer. If you have doubt in any of these questions, we can verify. Go ahead. There is 2 problems in your assignment, okay, which is on steam table. 7th is in the steam table question, and I guess 9th is also the steam table question, which you have and which will be equated by only this formula of work out, work in, and these values. So if you want, we can also go ahead with you can do the question number 6 in it, question number 7th also from steam table, which is on water and at 1 atm. So if you want to see this question in your I can show you also that the question you want, there's this question number 6, an adiabatic heat exchanger, which you have, no, 7th question, water is boiling at 1 atm pressure in stainless steel pan. So this question is similar to our question which we have done, where you need to understand, use the steam table, and you have to understand. So when they have said adiabatic means there is no Q loss. So when there is no Q loss, you will be able to get what is it. So there you don't have to use Q loss, you just have to find the Q, the heat, which will be equated by the empty dot into Hg minus Hf. So remember this, that for adiabatic, when we say that for adiabatic, there is no need of, for adiabatic there is no heat, Q, there is nothing, so there won't be Q losses. Q loss, where there will be no Q loss. So in question number assignment question number 6, I'll say question number 7th, there be no QL. Rest everything will remain same. You should know how to see a steam table. Please, I hope you got the answer correct. We can discuss it more further if you don't know how to use the steam tables, but in prerequisite I told that you should know how to use a steam table if you have 2 conditions given. Let's go further and go to our last 3 questions which are there. If so, till now, let me go through what we have done. We are able to define our zero law. We were able to define our first law. Then we understood what are the systems: closed system, open system, and adiabatic system. Then we understood that what is an extensive property, what is an intensive property, reversible and irreversible properties we have understood. Then we went to state function and parts functions. Then we went to what is internal energy as a state function. Then we solved problems on first law. We understood the first law problems very easily, and then we went to the problem of reversible and irreversible process work done, where we can use the ideal gas law. And then we went to the concept of no phase change heat exchange, which has been given by Q equals to mCp delta T. And there also I am just told you about the adiabatic heat exchanger process, where there is no heat given to the system or given out to the system, where you just have to equate Qn is equals to Q out, which is there in your system. Then we understood the Joule process, where Joule process has given us the idea of internal energy, work done, and heat exchanger. And then we understood the steam table, understand about the turbines which are there, how to solve the turbine problems with adiabatic reaction and non-adiabatic reaction. So now 14th question, let's go now to the 14th question. A heat exchanger is used to heat cold water at 15 degrees Celsius, entering at a rate of 20, I guess. So let me see. 14, yeah. Entering at the rate of 2 kg per second. Hot air at 85 degrees Celsius, entering at the rate of 3 kg per second. The heat exchanger is not insulated. So when you say not insulated, there will be Q loss. Just remember that. And is losing heat at a rate of 25 kilojoule per second. If the exact temperature of hot air is 20 degrees Celsius, the exact temperature of cold water will be how much? So as I told you, I have taken this question now to explain you the adiabatic thing has come into it, and we just have to solve it. So from previously I was telling you that adiabatic thing which I'll be solving further. So you just have to now understand that heat exchanger is used to heat cold water at 15 degrees Celsius, entering at the rate of 2 kg per second, and hot air at 85 degrees Celsius at the speed of 3 kg per second. The heat exchanger is not insulated, so there will be heat exchanger when it is not insulated. That itself means there is some Q L, and is losing heat at the rate of 25 kilojoule per second. Again, Q loss. Don't think that QL is by, but just I am taking Q loss as this. If there's okay, wait, there somebody in the meeting? Admit. Hi Rupali. Are you able to hear me? Rupali, are you able to hear me?
Yes, ma'am.
Okay. Rupali, do you have a specific doubt which you want to clear? I was actually going through the questions which are there already in the assignment, and I was completing it on question number 14th, which is relevant to your assignment number 1, question number 8. Do you have a specific problem, or shall I continue with whatever I was doing? Rupali, are you able to hear me? Okay. Okay, so going ahead with it, I guess Rupali will join further. Yeah. So if the exit temperature of the hot air is 20 degrees Celsius, the exit temperature of cold water in degrees Celsius is how much? So here the Q loss has come into the picture. So let's see how we will solve it. So the similar concept which I have told you, when there is no mass exchange, we will go by Q in minus Q out is equals to Q loss. Here it is the Q loss. So we just have to equate mCp delta T of air to mCp delta T of water plus the Q loss. You know m dot air is equals to 3 kilojoule, 3 kg per second. Cp of air as 1.005 kilojoule per kg degree Celsius, and delta T air is equals to 85 degrees Celsius minus the 25 degrees Celsius. So this was the value which was given to us, and is losing heat at a rate of 25 kilojoule. If the exit temperature of the hot air is 20 degrees, so like 85 minus 25, and then it was given that 15 degree was the in of air. So out wanted for the cold temperature. So let's start solving this. You just have to equate two values. So this is the data for value m dot of water, Cp of water 4.18, and delta Tw out of this. Putting all values in equation 1, we can go ahead and solve into mCp delta T is equals to mCp plus the Q loss, where you have to put the Q loss, which I have taken as 25, and you can go ahead and Tw out will come out to be 35 degrees Celsius. This will be your answer. Please solve it. You'll be able to get this answer. That you have to do, what you have to do, you just have to do 25 kilojoule per second. So it is not insulated, so 25 kilojoule per second will be the answer for it. If the exact temperature of hot air is 20 degree and the exact temperature of cold water is in degrees Celsius is 35. Okay, is everyone able to solve the problem? So the basic problem which I told you, question number which is there also in assignment, which was this problem. Actually question number, I have taken that as well. Wait, yeah, here we have taken this thing where there was nothing of as such of adiabatic loss. Here there is a loss. There in question number 14 we will take account of the loss is 25. Okay, I hope you get that. So you have to just add 25. I have not added this value just to remind you that there will be a loss also of 25. You can add that, and I will also correct this thing. So Tw out will be equals to 35 degrees Celsius. Take 2 or 3 minutes of time to understand that, and we can go ahead with the next problem. So you just have to equate this formula of mCp delta T to mCp delta T of water with Q loss, and you just have to find out m dot air, Cp of air, and delta T of air. So m dot water is equals to 2 kilogram per second, Cp of water is equals to 4.18 kilojoule per kg degree Celsius, and delta Tw out is equals to Tw out minus 50. So I hope you are able to get through these values and solve it. So let's go to our next question, the preceding one. For an ideal gas, relationship between Cp and Cv is, and what is dH by dt? So for an ideal gas, what is the relationship between Cp and Cv, and what is dH by dt called? So this is because I have chosen this question. Why? Because there will be many questions in your assignment which is related to it. So you should always remember this formula in your JEE times. I think so you must have done also that what is the relationship between ideal gas thing, and what is the constant Cp value, what is the Cv value. Okay, so for an ideal gas, the relationship between Cp and Cv, think about it for 30 seconds and then we will answer it. And what is dH by dt? That is like what is the enthalpic rate is called, and what is, and so this is a very conceptual question which everyone should know, and that's why I put it. So as we know, you should always remember that Cp is equals to R plus Cv, and dH by dt is equals to Cp value. So it's a And you should also know this thing, that this equation indicates that the rate of change of enthalpy with respect to time is equals to heat transfer at constant pressure. This relationship is derived from the first law of thermodynamics, which states that the change in internal energy of a system is equal to the heat added to the system minus the work done by the system on its surrounding. So if you want to derive it, it is also there in lecture number 5 that they have related this with the change in enthalpy. So going ahead with this problem, you should understand and solve this problem. So it uses this concept that Cp is equals to R plus Cv and dH by dt is equals to Cp. So now we got Cp is equals to dH by dt. Let's solve the other question. Okay. An ideal gas has a gas constant value of R equals to 0.3 kilojoule per kg Kelvin and a constant volume specific heat Cv equals to 0.7 kilojoule per kilogram Kelvin. If the gas has a temperature change of 100 Kelvin, the change in enthalpy is in kilojoule per kg. So you have R value given. They are at a constant value, so Cv value has been also given. If the gas has a temperature change of 100 Kelvin, so dt value has been given to you. If you see the change in enthalpy, we know how much will it be. We know from our previous thing is equals to Cp delta T. You know temperature change has been given to you. Cv value, now what you want is Cp value. If Cv you have, if you have R value, can you find Cp value? Yes, of course. See this previous question, Cp is equals to R plus Cv. Do it. Try to see the value change. I am giving you 30 seconds to try to solve it, and then we will match the answer and I will show you the solution. Okay, so the answer to it is 100. Let's solve this problem. So as we know, Cp minus Cv is equals to R, Cp is equals to R plus Cv. So what will be Cp? 0.3 plus 0.7, because it has been given here. R equals to 0.3 kilojoule. If check the units always. Kilojoule per kilo Kelvin, 0.3, 0.7. So this is 1 kilojoule per kg Kelvin. Also we know that delta H is equals to Cp delta T. Delta H is equals to 1 into 100, because we got the 1 kilojoule per kilo value is equals to 100 kilojoule per kg. So answer is delta H is equals to 100. Take your time to do this question, and when we will go ahead with another problem, which is on non-ideality. So this question itself is in your assignment, and I tried to solve it for you guys. So I hope you are able to understand this question. So question number 16 is done. Let's go to question number 17. Or one important thing, anybody knows about compressibility factor? What is a compressibility factor? A factor that accounts for the deviation of real gas from the ideal gas behavior at a given temperature and pressure. So PV equals to ZRT. Z is equals to PV by RT. So Z is basically V actual by V real, V ideal. So gas in real sense, ideal gas, for ideal gas, we assume that there is no interaction at all. Everything is a point mass and there's no interaction between them. Okay, they don't interact with each other and it has negligible volume. So, but in real gases, what happens? There is no assumption. There, in real world, there is an attraction, which is by van der Waals gases. It is given by P plus A, P plus A n square by V into V minus NB equals to nRT. So basically, if I'll say that Z is that factor when is equals to 1, PV is equals to RT, it will follow an ideal gas, other than it will tell you an ratio or the change that V actual by V ideal. The compressibility factor is unity, that there is no deviation from ideal gas because it is an ideal gas. And for real gases, it can be equals to 1, it can be greater than 1. So when Z is equals to 1, it will behave like an ideal gas. For real gas, it can be greater than 1 when that V actually is much more than the V ideal. So it accounts for the ideal non-ideality. Compressor accounts for the deviation of real gas from the ideal gases. So at a given temperature and pressure, it will tell about these things. So at what condition a real gas can behave like an ideal gas? Is it high pressure and high temperature, low pressure and low temperature, high pressure, low temperature, low pressure, and Z? So we now know that there is an ideal gas, there is a real gas. So if I'll take these things to particles to be an ideal gas, if these particles to be taken as a let me change my pointer color to red. Oh god, what is happening? Yeah, so there's these real gases which are close by. So if I want, this is a real gas, and if this is an ideal gas, this ideal gas and real gas, at what condition it will be? And this is, if you have read those chapter, high pressure and high temperature, it is respected to the critical temperature of that object, of that gas. It is actually the critical, if you know this is the thing, it is actually after that critical temperature. Is it high pressure or high temperature, low pressure or low temperature? So when at what temperature? If it is at high pressure, if I'll put high pressure on these things, will it behave? It will come more closer to it. So no, at high pressure that V actual will become very less than the V ideal thing. At low and at high temperature is what? High temperature will move it away. So it will be, so high temperature is one, can be the point. At low pressure it wants to be not interact, it will go far from each other. So low pressure can be there. If low temperature I will come, low temperature it will also reduce it, it will make it more firm. So low temperature, high pressure we have itself shown that low pressure. So the answer for this is low pressure and high temperature. Low pressure and high temperature will actually, at high temperature the gas can behave like a like an ideal solution. So thank you all for attending this lecture. I have tried to cover everything like compressibility factor, non-ideality. Then we have seen like Cp and Cv values, how to calculate heat exchangers, steam table use of turbine balance, then using the formula of mCp delta T, where taking reversible works into picture, relating it to our assignment problems, and what are the state and path functions, reversible and irreversible process, extensive, intensive, open system, first law and zeroth law. So everything, after covering all these things, I would like to conclude my lectures by of this week 1 assignment. If you have any problem, you can tell me whatever uh, you have doubts on, and I will try to post it out. I'll stop presenting my work first. Yeah, so that's all from my side. Thank you so much for attending the lecture. I will be also uploading on my YouTube channel, which you can verify it from. Every question has been kept into mind and made into the assignment form. Next Tuesday, let's meet on for the week 2 lectures, and we will be reading about it. Thank you so much. Bye. I am stopping the video.